AWS reInvent took place in early part of December 2024 in its usual location in Las Vegas, Nevada. This year was extra special. And I'm saying this because over the years, we have been used to watching AWS announce new products, new databases, new services ad nauseum. We come back from every reInvent. I had swimming with all of these new announcements. This year was no different, but for the last couple of years, we have noticed that AWS has taken a very starkly different approach, and this approach is completely grounded in enhancing and simplifying user experience. For example, last year, Zero ETL was a big announcement where operation database was behind the scenes, extracted and loaded into analytical databases. The users didn't have to do it, so you could have one place to do analytics or machine learning for your operational and analytical databases. This year, they took that to a brand new level, as you will see in a few minutes. This year was also the first keynote by the new CEO of AWS, Matt Garman. We have been used over the years watching Andy Jassy enthrall us for hours, talking about every new nuance of every new announcement. Matt Garman followed the suit. Not only that, Andy Jassy made a comeback and he did, as usual, a kick-ass job and told us to giddy up as he announced many of these new announcements. We also had fantastic keynotes by always colorful Dr. Werner Vogel, CTO of Amazon.com, and Swami, who used to run AI and ML in his early days, but now he runs all of data and AI. With that, my name is Sanjeev Mohan. As many of you know, not only do I host this podcast series, but I also am prolific on medium.com. I have my site, sanchmo.medium.com. In fact, this video is based on a blog I published on the key findings from AWS reInvent 2024, which you will find at sanchmo.medium.com. With that, let's go into how have I categorized various announcements. These categories are my own creation. These are not how AWS sees its new announcements, but this is how I wanted to tell the story, and I have compressed them in these various categories. The first one that you see here says unified data and analytics. So let's start with that because that was one of the key new announcements that came out of AWS. You will see this is a common picture that AWS shares quite a bit, and you will see the mention of Amazon SageMaker here. This, by the way, came as a surprise to all of us. Up to this point, we thought SageMaker was a product or an offering, or set of services. Actually, there are many, many services in SageMaker. We thought these services were only for machine learning and ML ops. But today, SageMaker is a brand which brings together, as you can see here, it says Unified Studio. There are 7 different services here sitting on top of a governance layer, and below that is a lakehouse. The 4 you see on the left are available. So if you look at data processing, it says Amazon Glue, EMR, and Athena. So this is how we process the data. Once the data is processed, we can see it through Redshift and do our analytics. We can do model development through something called SageMaker AI. So the original remit of SageMaker has now been renamed as SageMaker AI. But if you want to do generative AI development, for that you would use Bedrock. But Bedrock IDE is now built into Unified Studio, so you don't have to go to Bedrock service from the console. You can actually go straight into Bedrock from SageMaker. These 4 are already available. By the way, Unified Studio is in preview. I'm not talking about which ones are preview and GA because this changes all the time. So please check the documentation to see what's available today and what's not. The 3 that are coming soon will be making streaming data available through Unified Studio, and this comes courtesy of Amazon Kinesis and managed service for Kafka. or through BI, which comes through good old Amazon QuickSight, search through Amazon Search. This is, as I said, the picture that I borrowed from Amazon's many sessions where they announced this new unified approach. However, this was not enough for me to really understand and walk you through what is going on, because what AWS announced is not only groundbreaking, but it's also controversial. And to get to the nitty-gritty details, I've created my own schematic. Here, let's walk through how Amazon strategy comes to fore, but we will start at the very bottom at the storage layer. On the far left, you see Amazon S3 buckets. In 2006, when AWS was launched, it was launched with three services. Two of them were EC2 for compute and S3 for storage. So S3 has been around from day one. Over the years, S3 has really become the foundation for cloud native computing. Even today, if we look at how impactful S3 has been, over 400 trillion objects now exist in S3. S3 started as a very simple storage service. That's what S3 stands for. Over the years, they added different storage classes. But how does an end user know which is the right storage class to use? Many years ago, AWS introduced this concept of intelligent tiering, where they monitor the usage of your data. Depending upon how frequently or infrequently your data is used, it moves it into cheaper buckets, cheaper storage classes, which have lower cost but higher latency, but it's a trade-off. In fact, intelligent tiering, as we learned at this year's reInvent, has saved businesses $4 billion in their storage cost. So that is S3, which you can use today as you have in the past. But something that is brand new and caused a lot of excitement is this concept of Amazon S3 tables. This is a fully managed storage for Iceberg tables. It's optimized for Iceberg tables. What do we mean by optimized? Now, what happens in Iceberg is when Netflix first came out with Iceberg, which, by the way, is an open table format. I'm sure all of you know this, but it's not the only one. Uber came out with Hoodie way before anybody else, and then Databricks created Delta Lake. So there are three major open table formats. Iceberg was created at Netflix. It was not meant for streaming data in its original spec. So when a lot of data is coming into an object store, this data gets converted into Parquet files. Apache Iceberg table format sits on top. It abstracts the Parquet files, makes it look like a table. The table may consist of one or more of these Parquet files. And now with a table, you get all the asset semantics, you get schema evolution, you can do time travel. So you get all of that through Iceberg. But behind the scenes, it's ugly, because now you could have millions of Parquet files, small files. This is the problem of small data. So what compute engines do is when they see there's a lot of files with very tiny amount of data, they compact it. So there's a process of compaction that compute engines do. So for example, you may have hundreds of 1 MB files, you compact it into a single 512 MB file. By doing this compaction, what happens is that you now have one read that can look at the contents of a much larger table. So instead of multiple reads, you can reduce the number of reads, you can improve latency, you can improve cost, and so compaction becomes really important. Products like Snowflake, they do it for you. Even Amazon Glue does it for you. But by moving it into the storage layer, what AWS is saying is that, look, we've moved it to the lower level. So now you can bring any compute engine. They don't have to worry about compaction. We take care of compaction. It's not just compaction, by the way. It's also sometimes you are left behind with these orphan files that are just sitting around, taking up space, causing more processing reads to happen, which are of no value. So deleting these files is another thing that S3 table does. To do fully managed, a couple of things that you have to be aware of. The data must be in AWS's account, because otherwise it's very hard for AWS to manage uh, compaction and deletion of files if it is in somebody else's account. Second thing is there's also some cost involved. The cost of S3 tables is 15% over standard tables, and then there's cost for monitoring and compaction. Please note that these costs for compaction and monitoring is something that must be done anyway by users. Here, AWS is taking care of it, but then they're saying that you get 3 times the performance of native Iceberg tables and 10x transactions per second performance throughput. So, so that those are a few things that you have to keep in mind. But then the most controversial piece is that in order for AWS to commit data and have that consistency, they need to have a low-level catalog to do that. And that is something called S3 tables catalog. It is actually open source. And if you want to see the link to the GitHub repository, please go to my blog. I have the link to where you can find the code. Only a few engines support it. What it's doing is it has its own proprietary APIs, but you can put Iceberg compute engine on top. It can convert it into proprietary APIs. Today, there are only a few engines that are supported, like Spark and Flink. So the community has been a bit up in arms because they expect AWS to support native REST APIs, not proprietary. All I have to say is I don't have any inside information, but AWS has heard this news. All these things I'm sharing with you are literally a few weeks old. So who knows, over a period of time, AWS may have some new announcements on its roadmap. But for now, if you do have a REST compatible compute engine on top, and this could be Starburst, Dremio, any number of analytical engines, data processing engines that are REST API compatible. You can go through REST API interface into SageMaker Lakehouse. So SageMaker Lakehouse is actually the Iceberg REST catalog, or IRC. It is built on Glue Data Catalog. So it supports Glue Data Catalog APIs, but it also supports REST API interface. So you can bring any of your front-end tool and you can point it to SageMaker Lakehouse, which is a technical metadata catalog, and it will let you work on Amazon S3 tables out of the box. So that is how this space works. Now, AWS has gone even a step further. And some very exciting developments I want to bring to your attention are in the Redshift arena. So what is happening with Redshift? Redshift was the original data warehouse in the cloud. It started before these new cloud native data warehouses came into existence. So Redshift really had to go back to the drawing board and re-architect its backend to become more cloud native, i.e., separation of compute and store. So just like in Snowflake, you can have a common storage database, but then you can have any number of compute engines, one for ETL, one for BI, one for data quality, one for observability, or whatever different compute clusters you have. These compute clusters in Snowflake are called virtual warehouses, but they go against this common set of data sitting on an object store. So using RA3 instance type, Redshift introduced something called Redshift Managed Storage. Redshift Managed Storage basically stores all the data in S3. If the data is frequently used, it caches it into compute clusters, into SSDs, but the data is always in S3. So what is new in 2024? What is new is that now I can go into something called SageMaker Unified Studio. We talked about this in the previous slide. Here, I can say, go to my Redshift data or RMS, Redshift Managed Storage, and publish it. The moment I publish it, it creates entry into Glue Data Catalog or SageMaker Lakehouse, and it exposes my Redshift native data as Iceberg data. And so in some ways, it has actually gone a step further than Snowflake, because in Snowflake, you can use Iceberg to read and write and at same speed as proprietary Snowflake data. But Snowflake's proprietary or native format data is still only available to Snowflake Compute Engine. But in this case, what Redshift is saying is that all of our data, we can publish it as Iceberg data. So any Iceberg API compatible compute engine can now run the analytics natively on Redshift data. So that is something very interesting. What you don't see here is that Redshift has even taken it a step further. Zero ETL. So I talked about zero ETL from operational databases into analytical databases, but what we saw in 2024 is that AWS is saying, why just operational data? You can even bring your streaming data like CloudWatch. You can even bring enterprise application data through zero ETL. For example, if you have Salesforce or ServiceNow or SAP, Facebook ads, Instagram ads, Zoho CRM. So there are these connectors where they will extract data from these third-party applications that I talked about and load it into Redshift managed storage, which you can then publish as Iceberg, and you can now do analytics on third-party data or on native Redshift data. In fact, they also announced earlier this year a bidirectional interface with Salesforce Data Cloud. So all of this is how AWS is building its unified governed analytics strategy. But that is not all. If you notice here, there is yet another storage piece, and this is called SageMaker Lakehouse Federation. If for some reasons you don't want to move the data, you want to query it in place, query it where it already exists. This year, SageMaker Lakehouse Federation announced 6 new connectors. For example, if the data happens to be in Google BigQuery or in Snowflake, and you want to expose this through the Lakehouse catalog, you can now expose it through Lakehouse catalog, write your SQL queries, and the SQL queries will get routed to the sources directly. So it'll push down your queries to BigQuery or any of these other sources that have been announced. In fact, even the query engine has been rewritten. It used to be that the Redshift query engine was actually Impala behind the scenes, but now they have their own C++, highly optimized native engine that further improves performance of these of queries. So with that, we will move on to the next set of announcements, and for that, we will go to operational databases. The second massive announcement was Aurora DSQL. What is DSQL or distributed SQL? What exactly is that? So to understand that, I want to take you back to a couple of years ago. First database service that AWS announced was called RDS, Relation Database Service. They started with MySQL, then they added Postgres. Soon we see arrival of DB2, Oracle, SQL Server, MariaDB, and so on. So that's RDS, where AWS is taking a third-party database and making it work in its cloud. But that's not good enough. That's great, by the way, for out of the box. But if you want like highly efficient, highly resilient, multiple copies of data, all taken care by itself. Then for that, AWS created Aurora MySQL, and Aurora Postgres. So these Aurora, by the way, even today we were told many times is the most asked for or most demanded AWS service of all of its 200 close to 200 different services it has. So Aurora has been hugely popular over the years. It has also gone through its own gyrations and enhancements. For example, some years ago, AWS announced Aurora Serverless V2, where you would pay for Aurora on demand for the services you used. If you didn't use the service, the compute would shut down. But it never really shut down. It went down to 0.25 ACU, or Aurora Capacity Units. And that was it. So many people said, how can you call this serverless when it's not really going down to no compute, zero compute? This year in 2024, AWS announced that their serverless feature now completely goes to zero compute. So you do not pay for any usage when you don't use it. So that's the first big announcement. Last year, at 2023 reInvent, AWS announced Aurora Limitless. So one of the things with both Postgres and MySQL is that at any given time, only one writer is allowed to the same piece of data. So Limitless announces ability to support multiple writers. But how they support multiple writers in Limitless is you take your data and using some key, either hash key or range key, you partition your data, your storage of your data across different nodes. So then you can have different writers writing to different shards all at the same time. Using a single endpoint, what Aurora Limitless did was it put a router, and that router knew based on your write request whether to use standard PostgreSQL or to use sharded tables. There's also, by the way, Aurora can also create copies of commonly used reference tables across different shards. But there's a router that decides which writer to use for which shard. What was announced this year was a true active, multi-region, highly available database, and that is called Aurora DSQL. So imagine you have one table, but for some reasons, maybe it's compliance reasons, GDPR, some data must reside in an European data center and some data must reside in a US data center, but you are writing to data in many different places. It's highly consistent, but to do this kind of distributed write is a very difficult task. There are only a few databases that do it. A few of them that come to my mind are Yugabyte, CockroachDB, and then Google has had Spanner for many years. So what was announced this year was something like Spanner, Aurora DSQL. It is for Postgres compatible databases. What it does is it, for each compute node that is being used against the same piece of data, for each EC2, it puts a hardware reference clock. Because, and this is when earlier on I said Dr. Werner Vogel's fantastic keynote, he spent a lot of time on the concept of time. Syncing the time is a very critical task, because if the clocks are slightly off, you would not know which transaction came before and which came after on the same piece of data, and you can very easily corrupt your data. So Amazon uses something called Amazon Time Sync. This is a hardware reference clock, which is synchronized using satellites on all the EC2 nodes. Using that, they are able to then maintain consistency and know which transaction came after which, and then commit them accordingly. So that is a very big announcement. It's called Aurora DSQL. It's very similar to, by the way, Google Spanner, which has something called TrueTime, exactly the same concept of hardware reference clocks. I'll jump to number three and then come back to Neptune. In number three, DynamoDB also became multi-region, strictly consistent database using the same technology underneath that Aurora DSQL uses today. Neptune is one of my favorite topics, graph databases. Why I find graph databases intriguing is because the graph data model is exactly how we humans think. We think in terms of people and their connections to other things in life, like, there could be a node with me in it, and I work at a certain place, I live in a certain city, I interact with certain people. And so using nodes and edges, the entire data model is constructed. But now comes a rub. If it is that simple and that intuitive, why is graph databases not frequently seen and adopted? This is the disconnect which Amazon has been trying to solve for the longest time. The first problem was that the languages that were used were proprietary, Cypher, Gremlin, although very easy, but people don't want to learn a new language. This just in the last year or two, a new standard was ratified called SQL PG, or SQL Property Graph, which is using SQL with some extensions to do graph analytics. So although the language piece is getting solved, but still the problem persists with graph databases. So Neptune, which is a graph database, has introduced something called Neptune GraphRAG. So let's talk about this. So what is the purpose of RAG? Let's say I want to write a SQL query on data in PDF document. Obviously, I cannot go to PDF directly. So in case of retrieval augmented generation workflow or a pipeline, what I do is I connect to my data sources, chunk them up, create embeddings of the entities inside my PDF, store it into a vector database. Now I can use a natural language question, and through embedding done by an LLM, I can go against the vector store, do a similarity search, and try to find my answers in a very non-keyword, using this kind of a search technique. GraphRag takes it a step further. What it says is that we know that Gen AI models, they have a high level of hallucination. So what if we not only do embeddings and vector store, all of that, as we've discussed, and store it in Neptune, but we also take the entities and we create some sort of a graph, a lexical graph of entities. Now, every time we do similarity search, we will run the results through this graph, and we will further refine and re-rank our answers. And by doing this, Neptune GraphRAG can improve accuracy from 5 to 15%. So that is the whole idea. So prior to this, when I did vector embeddings, I would store my embeddings in OpenSearch, which is the elastic compatible search database. Now I can store it in a graph database and have a lexical graph, improve the accuracy of my work. GraphRAG is actually quite popular. In fact, Neo4j, which is the leader in this space, they do it. Microsoft has something called Lazy GraphRAG, where what they say is same idea, but instead of creating the vector embeddings and lexical graph earlier on, they basically create the lexical graph at query time, hence the term lazy. And Amazon has been studying all of these different approaches. This is, again, just got introduced. but next year we may see further enhancements to GraphRAG. We will talk more about this when we get into AI development space. But for now, I want to end this section by showing how we have expanded the gamut of where the vectors are stored in the Amazon space into all of these different databases, as you can see on this slide. We only talked about two non-relation databases, DynamoDB and Neptune, but there's so many more. There is DocumentDB, which is MongoDB compatible. There's Keyspaces, which is Apache Cassandra compatible. There is time series data, which is in TimeStream. In fact, there was some new announcement for TimeStream for InfluxDB. There is MemoryDB. Then there is KeyVal. There is ValKey. ValKey is a key value store which was created almost instantly the moment Redis moved from or changed their licensing from open source to more commercial terms. ValKey was created by both AWS, Google Cloud, and a few other vendors. And so that's another non-relational database. All of these saw a lot of announcements, but we are going to continue to our next series of announcements, which is in AI infrastructure. The first one I've listed here is Graviton 4, which is now generally available. Why is Graviton 4 such a big deal? I don't see or hear about Graviton as much, but I was quite surprised to hear that the amount of compute driven on Graviton today exceeds all of AWS compute in 2019. Graviton 4, a Graviton chip, and all of these other ASICs, CPUs, FPGAs, and GPUs, they have been phenomenal success of AWS buying Annapurna Labs out of Israel and building out all these chips. One of the new announcements was Trainium 2. This is a new GPU that helps you train models at 70% the cost of an NVIDIA GPU, for example. Trainium 2 is new. In fact, at the keynote, Matt Garman also announced Trainium 3. So next year, when we go for reInvent 2025, we will hear more about Trainium 3. But for now, let's stick to Trainium 2. If you take 16 of Trainium 2 chips and you put them together, you get a new instance type, which is called TRN2. This instance type, if you take 4 of them, in other words, 64 of Trainium 2 chips, connect them through a highly optimized chip-to-chip interconnect called Neuron Link, you get something called an ultra server. So these ultra servers are these massive racks of Trainium 2, and they are being used by companies like Anthropic to train their Claude series of frontier models. Interestingly, we are talking about two things. So I'm speaking from both sides of my mouth. On one side, I'm saying AWS has introduced new chips, and now next we'll talk about Nova frontier models. On the other hand, we are also talking about them partnering with Anthropic and NVIDIA. So it's an interesting world we live in where AWS is sticking to its mantra of giving users choices. You can either use native offerings or you can use third-party offerings, and they're both supported equally. So talking about native offerings, 6 new models were introduced, and they're called the Nova Frontier models. These are multimodal. They are used for text, images, videos. These support 200 languages. Why there are 6 of them is because they have different features. Some are text only, some are more creative, some support short videos. Also, their token size varies. I have more details in my blog on what are the 6 different types of Nova Frontier models. The important thing to remember here is that last year we learned about Titan models. Titan models are now retired because the Nova are the next generation of frontier or foundation models that AWS has released. But AWS is not just releasing its own models, it is also supporting NVIDIA and its partner GPUs. So for example, NVIDIA chips are supported through a brand new P6 instance. And you see here, up to this point, you have P5 instance, the different P5 instance types. What AWS is saying is that if you use P5, instead use Trainium 2, because Trainium 2 are far more cost efficient than P5. But if you want to use NVIDIA's latest Blackwell chips, then use P6 instance type. That takes us to a huge area which has to do with AI development. You can see there's like literally a slew of new announcements. I'll go through them very quickly. A lot of these were covered by Swami in his keynote. The first one is called Bedrock. Actually, the whole series is Bedrock. I could have put Bedrock before all of these things you see down here, but instead of repeating the obvious, I've just mentioned in the first bullet. What Bedrock does is it's fully managed access to a large number of models. So single API, but you get models obviously from AWS and Anthropic, its closest partner. In fact, I think AWS has now made $8 billion in investment into Anthropic. But also other partners like AI 21 Labs, Cohere, Meta, Mistral, Stability, all of these models are available through Bedrock. So that leads to a question, well, how do I know which model to use? Fear not. For that, AWS has released its Bedrock intelligent prompt routing, where it automatically can detect which is the right model to use for your prompts, and it routes it to that. And they have published some savings in my document. I talk about how much savings can you get by using the right model for the right prompt. That is not all. They also do Bedrock prompt caching. By doing prompt caching, they save you further 90% of your cost if that prompt has already been used and it is sitting in the cache. Then you don't have to make this expensive round trip into the LLM, incur the LLM API cost, and then get the result. You can get that data straight from what has been run in the past through prompt caching. Model distillation. This is very, very interesting. In fact, this whole concept where you take a larger model, you get rid of layers that are not applicable for your use case, and you convert it into a small task or domain specific model is a process of model distillation. You can take a 70 billion parameter model and turn it into a 7 billion parameter model, which you can then run on your edge device. And this way you get literally the same results and same accuracy as a larger model. But the difference is that you have constrained the data to your specific needs. So that is now available out of the box. Reasoning has been really big. So there's reasoning in the models. So we've in some of my previous videos, I've talked quite a bit about O3 or Google Gemini Flash thinking model, which are reasoning models. This is not reasoning model. This is taking the reasoning and doing some sort of predictive mathematics on the results that are derived from Bedrock, and then picking the right result, so improving the accuracy of your results at runtime is the purpose of model reasoning. Guardrails is a further offering that helps with responsible AI type of activities. And then we get to a multi-engine orchestrator. I've spoken quite a bit about how in 2025 we will see organizations building hundreds of agents for very small tasks or for small niche roles. So these are specialized agents, and there'll be many, many of them that will come together to run my workflow. How do I orchestrate across these different agents is the job of Bedrock's multi-engine orchestrator. Let's move on to the next one, knowledge bases for GraphRAG. So this we've already talked about. So when I talked to you earlier about how I can store vector embeddings now in Neptune, prior to this, I could only store it in OpenSearch. Now I can store it in Neptune, which is a graph database. So by doing this, I'm now able to have my RAG pipeline using Neptune. The service that gives me fully managed RAG pipelines with citations is called knowledge bases. But why just talk about PDF as my source and I'm doing all kinds of RAG on it? What about structured data? I should have the ability to run my RAG pipelines on Redshift or even SageMaker Lakehouse. That is a new announcement that came out. So now you have knowledge bases for Redshift and for SageMaker. So you can do exactly what we discussed earlier with unstructured data on now structured data. One of the biggest developments that also came out is called QDeveloper. QDeveloper was announced last year. This year, we saw it in action. QDeveloper was everywhere. It's embedded in various different products. It's an assistant where you can ask questions. For example, I can use QDeveloper for helping me write my code, for creating unit tests, for creating documentation. I can also use QDeveloper if I want to migrate or modernize my mainframe applications. I can also use QDeveloper on third-party products like Datadog, and I can ask questions against Datadog on various alerts, anomalies that have been generated in Datadog. So QDeveloper is also very popular. In this podcast channel, it depends. You can see a video that I did on site with the lead developer relations person for QDeveloper, and she explains how powerful QDeveloper has been. But why leave all of this fun for the IT people? What about the business people? What about their ability to ask natural language questions to documents that are sitting in SharePoint or emails in Gmail or Microsoft Office or Teams or Slack? For that, we now see Q Business has been developed quite a bit. In fact, I have a case study from Hearst also in my blog. With that, we go to the very last section. This is the machine learning development. We are back to SageMaker, but this time we are back to the original purpose of SageMaker, which was to do machine learning. Here, there's all the questions about what is the right model to use, how much compute resources should I use? How can I define that please use X amount of compute resources and then stop, or have all kinds of plans. So you see hyperpod task governance, hyperpod flexible training plan. A lot of partners, third-party partners, have now integrated with SageMaker, as has Bedrock. So with that, we come to the end of our discussion here. Thank you very much for staying up till the very end. It has been such a pleasure talking to you about various AWS reInvent key findings. Until next time, we will talk again. Thank you so much. Bye bye.